energy is a very important concept in chemistry and all of science. It takes energy to do stuff. If you're tired and you don't have the energy, if you say to do anything, whether it's walking, running errands, doing house, whatever it is, you are making a correct, scientifically speaking statement. So energy is the ability to do work, change matter, and I can add to transfer heat because we will talk about heat later on. So quickly, what are the types of energy? We have two types that we will deal with. The first one is kinetic energy, which is the energy of motion. When things are moving, so if you have, for example, a car, let me just get this to draw here. So if you have a car that's moving, if you have water running, so these are on the macro level. All of these are uh, examples of kinetic energy. You want motion, you need motion. And thermal energy in this context is what we are concerned with. So it's a type of kinetic energy. So if we go here, thermal energy is if you actually have water and you introduce heat, which is energy, into the water sample, what happens is that the water molecules will start moving faster and faster and faster. And that creates kinetic energy. We call that type of energy thermal energy. So if you want to go from liquid to gas, you are um, putting in energy, right? So the water sample, the system that we call here, is absorbing energy and it's making the water molecules move faster and faster. And of course, that leads to a phase change, which means that we have a physical change in this case. Of course, you can apply this to chemical change as well. Potential energy, on the other hand, is you can think of it as stored energy. So energy when that is resulting when a force is operating on an object or the composition of a substance. So for example, if you have a water slide here and you have this person right here, uh, you can see at the top that person has potential energy to, again, go down the slide. If you have a sugar molecule, that's why we need carbohydrates. When you actually break down that sugar molecule, you release energy for cellular work and heat. So chemical energy, and I'm actually going to give you another simple example of potential energy, but mainly we're dealing with chemical energy, which is potential energy. So it's the energy associated with the relative positions of electrons and nuclei in atoms and molecules, which is a form of potential energy. In short, basically, is that if you have every time you turn on the stove to boil something, to heat something, what happens is you are reacting this with oxygen and you are breaking these bonds. You can think of it that way to release. So you have here, you can think of it as you have potential energy. Which results in making CO2 and water. We get to these types of reactions in chapter 5 or 6. So you have that energy released from here. That's what we call potential energy. So this is how fossil fuel work. So another example is, again, think of just stored energy anytime you have stored energy. So for example, if you have a hill and you have a rock at the top of this hill and it starts rolling down, well, this rock has potential energy and it can impact whatever it is in its path, right? So that's an example of potential energy. Now, very quickly, let's talk about heat and energy. So our main concern is really with heat. So heat is the flow of energy from an object at higher temperature to an object at lower temperature. So we know that when you uh, grab something hot, let's say a hot piece of metal, you will burn yourself. But the reason why is because that heat, that energy will flow from that piece of metal, hot piece of metal to your hands. So this is what heat is. Heat and temperature are both a measure of kinetic energy, motion particles, and there is a unit here. It's expressed in heat is expressed in units of calories and kilocalories. So that's what calories are. So the definition of calories is the amount of heat necessary to raise the temperature of 1 gram of water by 1 degree on the Celsius scale. And kilocalories is 1,000 calories. So another unit that we really need to pay attention is when you have calories, and we will talk about this at the end of this lecture, if you have the capital C means it's a food calorie or a nutritional calorie, and it means 1,000 calories. So the calories that you read um, on the nutritional profile when you buy something from the store, whatever, that's in thousands of calories because 1 calorie, small calorie, is way, way too small. Having said that, we also want to talk about the unit of energy, joule, because that's really the SI unit for energy. It's joules. So when you have a calorie, that's equal to 4.184 joules. 1 calorie is 4.184. So it follows that if you have also 1 kcal, that you have 4.184 kilojoules.